Hello, and welcome to Physics Friday, a new show brought to you by Physics Explained. Let me break it down and explain what's going on. There are scientific discoveries made all over the world that go completely under the radar, and that is such a shame. So Physics Friday aims to bring you all the science news and facts from around the globe in this weekly show based on the articles featured on www.physicsexplained.co.uk. Unfortunately, science doesn't always run like clockwork. Therefore, the news you hear may not have happened that week, but certainly will have happened in the not so distant past. With that all sorted, let's get cracked on. And With that all sorted, let's get cracked on. We begin this week with a Bonfire Night special. Every year on November 5th, we remember the failed plot of Robert Catesby, a Catholic rebellion leader fighting the brutality of Protestant leadership. We tend to, however, focus on the York-born Guy Fawkes, the man caught red-handed with 36 barrels of gunpowder below the Houses of Parliament. That very night in 1605, villages throughout England lit bonfires to celebrate the safety of King James I. As I'm sure you know, this day is now usually celebrated with effigies of Guy Fawkes atop a bonfire and some fireworks. Fireworks are the main focus of Physics Explained today, and you can read into more of them on the website, but I will go into some detail now. There are three main concepts at play in a firework, the first of which is the fuel source. This involves a redox reaction between two reductants, charcoal and sulfur normally, and an oxidant, hence the name redox. The reductants lose electrons to the oxidants, and in this process, oxygen atoms are released inside the chamber. These oxygen atoms are then used to drive the combustion. The hot carbon dioxide and sulfur dioxide gases released in this combustion provide the firework with enough kinetic energy to overcome the gravitational pull of the Earth to reach a top speed of approximately 230 miles an hour at the top of its flight. Finally, at the top, for the colour of the firework, manufacturers use a variety of different elements to give the firework a spectacular colour. Common combinations include magnesium for white, copper for blue, and sodium for yellow. You can read the full story at physicsexplained.co.uk. In other news, you'd struggle to use social media every day and not hear something new about Donald Trump. But more importantly, America are now the only nation in the world not to have signed the Paris Agreement. This, and I'm quoting here, requires all the parties to put forward their best efforts through nationally determined contributions, or NDCs, and strengthen these efforts in years ahead. Now this doesn't actually require any immediate action on climate change, but Trump still refuses to sign. America has seen one of the worst hurricane seasons this year since 1851, and there is a direct link between hurricanes and climate change. Hurricanes are tropical storms. They are the same as cyclones or typhoons, but they form specifically in the Atlantic or East Pacific Ocean. They only form under the effect of high winds and relatively high temperatures. Wind is the convection current generated by temperature gradients between different regions, where high energy or hot regions, which are less dense, rise in their container, or for Earth's atmosphere. The low energy or cold regions, which are more dense, move to fill this region. Therefore, an increase in temperature directly correlates to high wind strengths. As the wind passes over the surface of the ocean, evaporated water in the form of water vapour is drawn into the air and rises due to the heat stored in the ocean. You see, the ocean is more dense than land and can store heat energy from the sun for longer. This is why, winds generally blow inland. As the vapour rises, it cools and condenses to form areas of water droplets that we call clouds. This releases heat energy to warm the air, which rises and is drawn into the cloud column. This process creates large moving clusters of storm clouds. The circular motion of vapour rising, air rising, and the air sinking through the centre of the cloud causes it to spin. The longer the storm spends over water, the larger and faster it becomes. The water is essentially a fuel source. The storm officially becomes a hurricane when the wind speeds reach 74 miles an hour. Usually, the storm slows down over land and causes devastation and destruction, as we've seen this year in the news. You can read the full story again on the website at www.physicsexplained.co.uk. And finally for this week, you may have seen last month that the Laser Interferometer Gravitational Observatory, or LIGO for short, which is an observatory for detecting gravitational waves, combined with orbital and land-based telescopes, were able to detect the exact moment two neutron stars collided 130 million light-years from Earth. A neutron star is the remnants of a relatively large star after a supernova if it is not large enough to fully collapse into a black hole. They are roughly the same size as our Sun, but immensely heavy. In 1915, Albert Einstein predicted that masses such as stars moved through space on a surface known as space-time, and that incredibly heavy objects were capable of distorting space-time, causing ripples like a stone in a pond. The detection of these gravitational waves by LIGO not only proved Einstein's theory, but allowed for the observation of a collision responsible for elements such as gold and platinum being distributed throughout the universe, meaning it has happened before. Work at LIGO has also led to 3 physicists based there winning the Nobel Prize for Physics this year, and you can read both these articles again at physicsexplained.co.uk. I'll be back with more Physics Explained articles and Physics in 5 videos in the meantime. I hope you enjoyed it, and I will see you next time. Thank you for listening.